all?
Yes, sir.
Everybody? Kiranya, Roshni,
Yes, sir.
Israel, Satya, can you listen?
Yes, sir.
Okay. So today's topic is we will discuss about Kepler's laws of planetary motion. Okay. So in your 12th class, in your gravitation chapter, you must have gone through the three important laws of Kepler's laws of planetary motion. And Kepler, actually, what happened? He gave these planetary laws much after the gravitational laws were given by Newton. So, based on the discovery of laws of gravitation, Kepler formulated three important laws which described the motion of your planet around the sun. All the planets, they follow this particular laws and they move around the sun according to the three laws described by Kepler. So, out of that, the second law, Kepler's second law, that comes from the fact that gravitational field of sun is a central force field. We have already discussed what is a central force, what is a central force field. So gravitational field is such kind of that. And the second law comes from that gravitational field of the sun. And other two laws, this is the result of your gravitational force that varies as inverse square law. Okay, you have seen the inverse square of the distance. So what does that say? It says that all the planets are trapped by gravitational force by the sun and their orbits around the sun are elliptical. They are not circular, they are elliptical. So every planet, it moves around the sun in an elliptical orbit only. Okay, so we will see these three laws, we will derive that, and let us first start with the first law of elliptical orbit. So the first law of elliptical orbit. First law of elliptical orbit. Okay, orbits you can say. First law of elliptical orbit. Okay, so what does this law tells you? It tells that every planet, all of you write down, every planet, I think my handwriting is not becoming good. Wait just a minute, I'm using this for the first time. Every planet moves in a elliptical orbit around the sun, around the sun, the sun being at one of foci. Okay, so before I proceed further, first of all, you let me know that यहाँ पे इस format में पढ़ना आपको ठीक लग रहा है कि I will open the Word file and I'll write there. Which one you feel comfortable? Let me know.
So this is fine.
It is fine. It is visible.
Yes, sir.
Okay. So every planet moves in an elliptical orbit around the sun being at one of the foci. What does that mean? That means that if this is your elliptical orbit, such that these are your semi-major and semi-minor axes. Let's say this is the point A, this is the point B, this is the point A prime, this is the point B prime, and this is O. Let's say the sun is situated somewhere here, that is S, and Earth is somewhere here, let's say. Okay, and it is moving around the sun in this particular orbit. So now we know that the distance, this distance is, let's say, 2a. That means we can say that this is the semi-major axis, that is A. Similarly, this is the semi-minor axis, that is B. Okay, and the whole A prime B prime is 2b. That means this A prime B prime is called minor axis, A B is called major axis. If you take half of that, that is A and B, that is called semi-major and semi-minor axis respectively. Okay, so let us first prove this. So before we start the proof, I think I have already taught you the differential equation of orbit. The differential equation of orbit is that is given by d square u by d theta square plus u is equal to minus m by L square u square f of 1 by u. Try to relate this one. We have already read this. So give equation 1 to it. Okay. Can you remember? Do you all remember this equation? कहाँ पढ़े थे ये equation? Try to recall the general solutions of your central force problem. You have one energy method, another one is Lagrangian method. So under that condition, this is the equation of motion. Okay, this is the equation of orbit, which is useful to find out the force law when the equation of orbit r theta is given to you. Okay, so under that condition, we have proved this. I think there you must have used mu. Okay, that is your reduced mass. Here I am using m. That is only difference. Okay, so let us proceed. So from this equation 1, and also we know that if any force, central force, it obeys inverse square law. For a central force obeying inverse square law. Okay, so this is the formula. F of r is equal to minus k by r square. That means what? That means the force is varying inversely with the square of the radial distance. So here we can see we have a negative sign. Negative sign implies the repulsive force between the objects. If this is positive, if this k is positive, it shows attractive nature. That is, you can take an example of gravitational force. That is attractive in nature, attractive force. But this is your repulsive force. So now let us assume that this r, let us assume this r is 1 by u. Okay, so f of 1 by u will be minus k u square, equation 2. Many equations are there in this topic, in this particular derivation. So be very careful while putting equation numbers. Okay, so now using equation 2 in equation 1, so you just substitute. So what you will get? You will get d square u by d theta square. All of you do it of your own. D square u by d theta square plus u. D square u by d theta square plus u is equal to minus m by L square u square, and in place of f of 1 by u, you can write minus k u square. So if you do the cancellation, you will get d square u by d theta square plus u. Bring this part to the left hand side. Here u square gets cancelled. Minus minus becomes plus. When it comes to this side, it is becoming minus mk 4 divided by L square. Okay, that is equal to 0. Give equation 3. Understood? So from this equation, we need to find out the solution of a equation. So what I will do here is I will reduce this equation 3 into a second order differential equation, so that my general solution to find out the second order differential equation will be easier for easy calculation. So what I will do is I will substitute, or I will assume this part. I will assume this part as, let's say, x. So what you write? Let's assume u minus mk by L square is equal to x. Give it equation 4. Okay, this is just to make your calculation much easier, so that we can find the equation of orbit. Understood? Are you following?
Yes.
Is it
Yes, sir.
visible and audible clearly?
Yes.
Everybody?
Yes, sir.
Okay. So now this implies I can write du by d theta. What will be du by d theta? This is your dx by d theta. Yes or no? Are you following? So from here I can get, this implies d square u by d theta square is equal to d square x by d theta square. So this is equation 5, and you have to substitute. So use equation 4 and equation 5 in your equation 3. See, equation 5 and 4 in equation 3. Just substitute here. So if you substitute, we will get a differential equation of second order using equation 4 and 5 in equation 3. What I will get? D square x by d theta square plus x equal to 0. Very simple equation. You must have read this kind of equation in your mathematics. Okay. So this is a second order differential equation. So for this particular equation, what will be my general solution? For equation 6, general solution is given as x equal to a cos theta minus theta prime. Equation 7. All of you see that this theta minus theta prime is a very important notation. Okay, this will help you to understand the aphelion and perihelion position of your planet around the sun. You will see that how it is helpful. All right. So from this equation 7, this a and theta prime are nothing but the constant of integration. A and theta prime is the constant of integration. So compare, if you compare this equation 7 with this equation 4, this one, if you compare, that is x equal to a cos theta minus theta prime, this is x equal to u minus mk by L square. So if you compare these two equations, on comparing equation 7 with 4, so what you will get? You will get that u minus mk by L square is equal to a cos theta minus theta prime. This is your equation 8. So from here you have to find out u. It's very simple. U is equal to, just take to this side. So this is your mk by L square plus a cos theta minus theta prime. And what you have considered already in equation 2, that your uh, r is 1 by u, so u is equal to 1 by r. So in that way we can write this as 1 by r is equal to mk by L square plus a cos theta minus theta prime. This is your equation 9. Is it clear up to this? Is it clear?
Yes, sir.
Okay, so this equation 9 is very important equation, one of the important equation you can say, because it will help you to understand the eccentricity of the orbit, how this eccentricity or the values of eccentricity, how it is changing, and how the ellipse will be, the path will be changing, why there is elliptical orbit, first thing. And also it will help you to understand the lattice rectum of your uh, any parabolic equation. Okay, or you can say here we don't have parabolic equation, this lattice rectum of your semi major axis. Yes, anyone is telling anything?
सर हमने यहाँ पे 1/r फॉर्म क्यों लिया?
Yes, I'm telling, because we need to find out this r in terms of your r minimum and r maximum, because हमको perihelion aphelion निकालना है. Okay, because you need to find out the potential part, effective potential. So effective potential, it all depends on r. And you know that effective potential is the sum of your potential due to central force as well as centrifugal potential also. So in all these things we have r. So just in order to correlate, it is better to write in terms of r. Equation is same. Okay, and from this equation I will separate out the centricity part as well as the lattice rectum part. I think eccentricity I have already discussed with you, but lattice rectum is a new term for you. I'll tell you in a few minutes. Just solve this one. So now what I will do is, in order to much again simplify this one, basically we need to write this particular equation 9 in terms of conic section, because you see that if I do the rough part here, you see that suppose this is your axis, okay, and let's say this will become a ellipse subsequently. Okay, so in that case I can consider this one as my foci where sun is situated, suppose. Okay, yes or no? Try to imagine this one. This is, let's say, your y axis. This is, let's say, it is your y prime. This is your x, and this is your x prime. So now what happens if there is a line segment that is perpendicular to the axis of parabola? This is the axis of parabola. If there is a line segment which is perpendicular to the axis of parabola, such that it will pass through the focus and the end point will lie on the parabola. What does that mean? That means if I draw a line like this, if I draw a line through the focus and it touches this point as well as this point, then I can say, let's say this is your P, this is your P prime. This P prime is passing through the focus. Then I can say this is the lattice rectum, because this part is what? This part is your semi-major axis. This is your, or you can say major axis, let's suppose. This is your major axis. So this one is your lattice rectum, this one. this dotted line which I have drawn here, P prime is your prime is your lattice rectum, and this lattice rectum, it has a general equation of a conic section. So what is the general equation of conic section? General equation of conic section is represented as L by R is equal to 1 plus E cos theta minus theta prime, where E is your eccentricity. So there is a correlation between them. So similarly, if I look at this particular equation, equation 9, there is a resemblance between these two equations. Just a small difference is there, which you can find out that in the left hand side, we do not have L by R, we have only 1 by R. Whereas here we have some factors, but we need 1 here. And this is A cos theta minus theta prime. So now what I will do is, I will compare this equation 9 with the conic equation. Okay. And from this comparison, I can find out the lattice rectum as well as eccentricity. So here, from this conic section, your L is called your lattice rectum. So what is your lattice rectum? It is a line perpendicular to the axis of parabola, which will pass through the focus, and the other 2 points will definitely lie on the parabola. That means what? Just write down, then I'll show you. And this E is called your eccentricity. Okay. So what do you mean by the points which will lie on the parabola? That means, suppose this is sun and suppose Earth came here. So what will happen? This Earth will face, or it will have a larger velocity. The angular momentum will be larger. Angular velocity will be larger when the planet is close to sun. When the planet is away from the sun, its speed is slow, comparatively slow. It's not very slow. It is comparatively slow than the planet placed at this point. So what will happen? Immediately the path will be curved and it will pass through this and P prime, and then it will deviate. So in this way, a elliptical path is formed. Did you understand? Is it clear?
Yes, sir.
Okay. So now what I will do is, I need a L here. So what I will do is, I will multiply this factor because I need 1 here. So what I have to do? I have to multiply L square by mk throughout the equation. So multiplying L square by mk in both the sides of equation 9. What I will get? I will get L square by mk whole divided by r, that is equal to 1 plus L square by mk is your A cos theta minus theta prime. This is your equation 10. So now you compare this equation 10 with the general equation of conic section, which I have written over here. So suppose you give an equation number, this one to, no need to give an equation number, just you compare. So you can write comparing equation 10 with general equation of conic section L by R equal to 1 plus E cos theta minus theta prime. So if you compare with this one, then we get L is equal to Just a second. Latus rectum is capital L. This one is capital L. So let me write here. Yes, L by R. So your L is equal to L square by mk, and L square by mk, and E is equal to L square A by mk. So this one is called your latus rectum, and this is called your eccentricity. Okay, is it clear?
So, you differentiate the small L and capital L.
Not audible again.
So, what is small L and capital L?
Yes, this one is small L and this one is capital L. Any one you can take. It is not like that. You can take this as capital, this as small, but you need to define. तो यहाँ पे L को मैंने define किया.
So, like
Okay.
capital L is equals to small by R.
Hello.
Hello, sir.
Am I audible? Yes.
So, like the small L is equals, sorry, the capital L is equals to the small L by R.
You have to compare equation 10 with this one. If you compare this one with this equation, then this L is equal to this numerator. That is your lattice rectum.
Okay, sir.
Understood?
Yes, sir.
Okay, so we got lattice rectum as well as eccentricity. So now what you have to do is we need to find out the energy of the particle that is moving under central force field. So how to do that? Let us first differentiate equation 9. Differentiating equation 9, what you will get? Minus 1 by r square, and this is your r dot, that is equal to, you can see in equation 9, this is equation 9. Yes, so this part will be 0. So 0, then plus, and this is cos. So derivative of cos is, okay, so this will be minus sign. So I can take minus here. Okay, so this is minus a sin theta minus theta prime and theta dot. Okay, this is your equation 11. And we have found the angular momentum, since we already know that angular momentum is equal to mr square theta dot. So from here I can find theta dot is equal to L by m r square. Okay, so just substitute this equation 12 here in equation 11. So what you will get? So we will get r theta is equal to this minus minus get cancelled. 1 by r square will go to the other side. That becomes a r square sin theta minus theta prime, and it was theta dot. So what is theta dot? It is L by m r square. So r square gets cancelled. This implies r dot is equal to a sine theta minus theta prime L by m. Okay, is it clear?
Yes.
To give equation number 13. So you have to use this equation to find out your energy of the particle moving under central force field. Now energy of particle moving under central force field, because our planets are moving around sun and gravitational force is a central force field. We have already discussed these things in the previous classes. So since it is moving under central force field, so energy is written as half mr dot square plus the potential part. It's the effective potential, that is V of r plus L square by 2mr square. Already we have deduced this equation in your previous classes, so you can see that. So from this equation, this part is called your effective potential. So this effective potential is the potential due to central force, that is V of r, plus centrifugal force, that is L square by 2mr square. And this V of r is a attractive potential. Okay, understood? Any doubt up to here? Is it clear to all?
Yes, sir.
Sir, can you explain
Okay.
again that how that conic section general equation is compared to the equation 10?
Okay, is it visible? Okay. So you can see it in the equation 10, sorry, equation 9. If you look at equation 9 and this part, suppose in a graph you have a parabola. In that parabola, if you have a line segment that is perpendicular to the axis of parabola, which one is axis of parabola? This is the major axis. Y prime. This is the major axis. Okay. Let's say, suppose this is O. So this Y and O is the major axis. All right. So to this major axis, if you have a line, if you draw a line that is perpendicular to this major axis, as well as it should pass through the focus, should pass through the foci. Okay. Then the end points will lie on the parabola. If this is the case, then this is the equation of conic section. And equation of conic section is given, the formula is this one. L by R is equal to 1 plus E theta cos theta minus theta prime. And here your E is eccentricity and L is your lattice rectum. Similarly, in equation 9, you got 1 by R is equal to this term. Okay. So we need to compare this equation 9 with the general equation of conic section. So if you compare, you have L by R, whereas in equation 9, you don't have L by R. You have only 1 by R. So we need a factor there. तो हम क्या करते हैं, सिंपल L मल्टीप्लाई कर लेते तो भी चलता है, दोनों तरफ L मल्टीप्लाई कर देते हैं. लेकिन if you see the equation of conic section, you have 1 plus E cos theta minus theta prime. You have a factor called 1. The first term is 1 here. Okay, but here you don't have 1. To make it 1, you need to multiply L square by mk both the sides. So if you multiply this factor in the left hand side, then that itself becomes the eccentricity, becomes the lattice rectum. That is L. So now lattice rectum becomes L square by mk. So latus rectum by R. Now you got one comparison. Similarly, this part will cancel out and it becomes 1. So 1, 1 plus A cos theta minus theta prime. So here A is also the constant of integration. So this one is also coming from that. So E is the eccentricity. So if you compare all these things, then you get this particular equation where I can say that the eccentricity is L square A by mk and L square by mk is your latus rectum. Understood? Or else you can say in this way also that your eccentricity is nothing but your latus rectum multiplied with A, some constant, isn't it? Because E is what? L square A by mk. And what is your L square by mk? That is latus rectum. So E is equal to latus rectum multiplied with some constant. That means eccentricity change होगा तो आपका latus rectum भी change होगा. That means what? For example, if you have a elliptical orbit for, let's say this is the elliptical orbit for Earth, then you have another elliptical orbit for, let's say, for another planet, Mars. तो सन इसके लिए सपोज यहाँ पे है, सपोज इफ यू टेक द सेमी मेजर एंड सेमी माइनर एक्सिस, okay, suppose this is the sun position, so this is the foci and this is the nearest approach, so you can say this is the perihelion region and aphelion region this side. So this is the closest approach, and when any planet comes to this closest approach of sun, then it will move faster as compared to planet here. Suppose this is sun, this is, let's say, earth, so earth will move faster from here. As it reaches here, it will move slower. So you cannot say that the earth is moving at a constant velocity around the sun. You cannot say that. It is not a constant velocity. Velocity is changing, but that change in velocity is very small. It's not a huge change. The same thing goes for all the planets. So as eccentricity changes, your L also changes. L means what? L is the latus rectum, that is the distance between these 2 points of your parabolic path. So if I take 1/2 of this ellipse, then isn't it what I'm getting this parabolic path? Suppose मैं इसको अगर joint कर देता, अगर ये इसे joint हो जाता, तो ये एक ellipse बन जाता कि नहीं? ठीक है? तो ये उसका क्या होता? एक foci होता, या फिर यहाँ पे sun का एक foci होता. Maybe sun is either here or here, but not at the center. Okay? So in this way, you can relate this equation 9 with this equation of conic section. So if you compare, you will get that your latus rectum is L square by mk, eccentricity is L square A by mk. Is it clear now?
Yes.
Roshni,
Yes.
what about others? Is it clear?
Yes, sir.
Okay. So from this equation, we can see that this part is called your effective potential, and this is due to the central force, potential due to central force, as well as centrifugal force. And since we know that this V of R is equal to minus K by R. Already we have seen this one. Okay. So this is the attractive potential part. So E is equal to half M R dot square minus K by R, and this is your plus L square by 2M R square. This is equation 14. Okay. Is it clear? Is this clear? Have you all written up to this?
Yes, sir.
Everybody has written? Everybody has
Sir, I'm
written?
writing.
Okay. Shall I proceed?
Yes, sir.
Okay, so this is the energy expression. Now what we need to do, we need to again simplify this one. So what you have to do is you have to substitute this R dot value. From where you will get that? You will get from equation 13. And also you need to substitute this value. So this one you will get from equation 9. All of you see your equation 9. Okay, in equation 9 you had your 1 by R term. So that you will multiply, you will, sorry, substitute. Okay, so let us write that using equation 9 and 13 in equation 14. If you substitute, what you will get? You will get E is equal to half M, this is AL by M sine theta minus theta prime, half M R dot square. So this is your R dot, AL sine theta minus theta prime. And since I am doing the square of that, so I am getting M square. Okay. Is it okay?
Sir, can you scroll a little down?
Just a second. Yes, this is okay. AL by M sine theta minus theta prime minus K by R. So K तो वैसे ही रहेगा. What about 1 by R? So 1 by R from equation 9 it was mk by L square, mk by L square plus a cos theta minus theta prime. Okay, theta minus theta prime. Okay, and plus L square by 2m mr square. So plus this is L square by 2m r square. So L square by 2m वैसे ही रहेगा 1 by r square, यानी कि इसका स्क्वायर, that means is your mk by L square plus a cos theta minus theta prime whole square. These are all simple mathematical equations. We need to do it properly, carefully. Okay. So when you simplify this one, I'm not doing the simplification. On simplifying, I'll write the direct answer. So you do the simplification, you do the cancellation and all these things. So final expression what you will get is E plus mk square by 2L square equal to a square L square by 2m. Okay. So from this expression, you need to find out a square. So a square is given as, if you take to this side, it becomes 2m by L square, then this part, E minus, sorry, E plus mk square by 2L square. Okay. Further, what we can do is we can bring this part outside. That means mk square by 2L square. So what will be left out? This will be E divided by mk square by 2L square. So it is multiplied here, it has to be divided. Plus, as you have already taken this as common, so this is 1. Okay. So doing the calculation, this 2 gets cancelled, and this becomes m square k square by L4. That means this implies a square is equal to m square k square by L4. This is 1 plus E, and this is 2L square goes up to L square E by mk square. 2L square E, yes, 2L square E by mk square. So on further solving, if you take the square root of that, m square k square by L4 becomes mk by L square, and this is root over of 1 plus 2L square E by mk square. Okay, understood?
Can you scroll a little up?
ओके
मैंने ऊपर का थोड़ा सा इक्वेशन छोड़ दिया.
कहाँ पे कौन सा इक्वेशन नंबर बताओ 14
सो 14 वो जो इक्वेशन 19 और 13 को हम लोग इक्वेशन 14 में डालते वो वाला. सो एक मिनट.
carefully लिखो everybody has to write very carefully is it okay shall I go down
यस.
this part you have written
यस.
this part
यस.
okay so let us proceed so now actually you got a value a is your constant as I told you and you just go to the eccentricity where we have found this eccentricity and latus rectum yes this one our important factor is eccentricity okay ये मिल गया तो latus rectum भी इसके साथ related है okay because eccentricity has a relation with latus rectum so we need to look after this equation as you can see here E is equal to L square A by mk so you just substitute A value whatever you got here okay so what you need to do is since centricity E is equal to E is equal to L square A by mk this implies E is equal to L square by mk and what is your A mk by L square 1 plus 2 L square E by mk square and this is the root over. So this gets cancelled. So finally this implies eccentricity is equal to 1 plus 2 L square E whole divided by mk square root over. So this is your equation 15. This is the eccentricity. Okay. So if you solve this equation 15 to find out energy equation, okay, on solving equation 15, we can find out energy. So basically you need to do the square of this, simple. If you take the square of it, this goes, there is 1 plus 2L square E by 2 by mk square, 1 goes to this side. So basically you will get, and this factor goes to that side. That is mk square by 2l square, and this is your e square minus 1 is equation 16. So I can say that energy is depending on eccentricity because this is a constant factor. So this is a constant e square minus 1. So from this expression, I can get 4 different conditions. Okay, I will get 4 different conditions based on this equation. 4 conditions, or you can say the conclusions regarding your equation of orbits. Okay, 4 conditions of orbit. The first condition is when your eccentricity is greater than 1. Second condition is eccentricity is equal to 1. Third condition is eccentricity less than 1. Fourth condition is eccentricity equals to 0. So for eccentricity greater than 1, all of you go to this equation 15. Eccentricity greater than 1 मतलब क्या? Energy क्या होगा? Greater than 0? Yes or no? Eccentricity is greater than 1. So energy will be greater than 0. For eccentricity equals to 1, so 1 square minus 1, so your energy is becoming what? 0, isn't it? Yes. So eccentricity less than 1, then your E will become negative. Energy is less than 0. For E equal to 0, your eccentricity is equal to minus mk square by 2l square. Okay. What will be the structure of orbit, or you can say nature of orbit? The nature of orbit here for eccentricity greater than 1 is hyperbola. For eccentricity equals to 1, energy equals to 0, it is the condition of parabola. For eccentricity less than 1 and energy E less than 0, it is ellipse. And this is okay. So based on these conditions, you can draw draw the path of your orbits. Like for eccentricity equals to 0, this is a circular orbit. Okay. Then slightly this circular orbit gets deviated. Drawing option is not visible. Okay, let me draw them. So let's say this is your circular orbit. Now from this circular orbit, gradually this path will be like this, goes like this. Okay, so this is my elliptical path. Again from here, the path goes like this. So this is your parabolic. Again from here goes like this. This is your hyperbolic. So here we will get for E greater than 1 is hyperbola. This is your E equal to 1, that is your parabola. This one is E less than 1, it is ellipse, and this one is, if I take this like this, then for this one it is E equal to 0, that is circle. Okay, so these are the conditions which will tell you the nature of the orbit. Yes or no? Is it clear up to this? Is it clear? Yes
Yes,
or
sir.
no?
Yes, sir.
Okay. So any doubt you have up to here?
No, sir.
All right. So let us stop here. So we will meet in the next class, and then we will continue the law of period. Okay. That means how the time period is related with your semi-major axis. You must be knowing about this one. That is laws of period. So basically, what happens here? The square of time period of the revolution of a planet around the sun, that is directly proportional to the cube of semi-major axis. Understood? So that relation we'll see it in the next class. All of you practice up to here. It is very important topic. Those who are absent, you share your notes, and those who are present right now, you practice these things properly once again. Okay. So let's stop here. Give your attendance, then we leave.